All right, any second now. One more minute to go, and then we're going to kick things off as we're getting to critical mass, I think, now. So 1 more minute. All right, welcome guys to the second ever TensorFlow.js community show and tell. I heard you wanted more, so I've managed to get 8 new presenters from all around the world to talk about their awesome work here with us today. We also heard that Asia and Europe wanted a friendlier time to join live, so I'm happy to be doing this second show and tell in a time zone that's more friendly for all of you this time around, even though it's 1 a.m. and maybe 4 a.m. for some of the folk on the call here today. Going forward, I'll probably alternate between the two, US and Asia, friendly timings for each show and tell that we do, just to make sure it's fair for everyone. As always, a massive thank you for joining live and inviting your friends to come along too on this epic adventure. So thank you very much. Now, for those of you who don't know me, my name is Jason Mays. I'm going to be your host today. I am the developer advocate for TensorFlow.js here at Google, which basically means if you're using machine learning anywhere on the web in JavaScript, then at some point there's a good chance our paths will cross and I magically appear, especially if you're using the Made with TF.js hashtag on Twitter or LinkedIn or other social channels. Now, if you enjoyed today's session and you want me to do even more of these in the future, then do let me know in the comments or on other means, whatever you so desire. And it's great to hear the feedback so I know if this is working or not for you. As a developer advocate, community gatherings are just one of the things I could be doing with my time. So I could be making more prototypes for you, presenting at conferences or writing up case studies and so on. So let me know what you'd prefer. Essentially, my job is to work with the product team directly and put myself in your shoes by literally being in the trenches, coding alongside you to make sure the developer experience is as good as it can be. And I personally would love to see more of your work being shared to inspire others in the community to take their first steps as well. So please do let me know what you want to see more of. Now with me today, I have 8 wonderful presenters. And if I switch to the other screen here, you can see them all waiting eagerly to talk in just a few minutes. We've got people from all around the world today. We've got people from Americas, Europe, and Asia who will be showing you what they've created in TensorFlow.js over the recent months. We have John and Var, Cyril, Follow the Dark Side, Jaume, Alessia, my bad, sorry, Alexandra, Amrita, and Shan. So basically, they'll all be talking today, and they've got 10 minutes to show what they've created using TensorFlow.js. But before I hand over to them, I'm also aware that our audience is from very diverse backgrounds, and some of you may be experts in machine learning, but new to JavaScript, and maybe you're looking to amplify your research using the reach and scale of the web, and others of you may be new to JavaScript, trying to take their first steps with machine learning. Now, some of you may be new to both, and that's completely fine too. In fact, in the first show and tell, I covered some of the ways you can get started with zero experience. So if you're feeling inspired after what you see today, you can go check out the recording of the first one to learn more about how to use TensorFlow.js. For those of you who didn't see the first show and tell, I'll very briefly do a super short recap to show you what this is all about, so you have some context for what you're about to see. So, on that note, TensorFlow.js is essentially a library that allows you to do machine learning in JavaScript. If you're completely new to machine learning, we make it super easy to get started using our pre-trained models that you can use out of the box, just like any regular JavaScript class that you might be using already. And there's no need to understand the machine learning stuff straight away if you don't need to. Now, if you're already a pro at machine learning, maybe using Python already, we have pretty much the same level, high and low level APIs as we do in Python, but in JavaScript land. And now that you know what TensorFlow is, why do you care about doing machine learning in JavaScript? Well, first up, JavaScript is the only language, or one of the only languages, that can run in almost any environment. Right now, for example, it can run in the web browser, on the back end, on the server side with Node.js, within native apps with React Native, desktop apps in Electron, and even Internet of Things devices like a Raspberry Pi. Now, if we focus on just the web browser for a moment, as most of our demos today will be happening in this environment, you get 4 further superpowers. The first one is privacy. By performing auto predictions and inference in the web browser directly, none of that data is sent to a third-party server. And that means the user's privacy is maintained. And in current times, privacy is the top of many people's minds, as we all know. The next up is speed. latency is reduced as there's no round trip time to the server, so you don't need to have that delay in getting the results back. So now you can have a much faster experience by running it on the edge. And linked to that, of course, is cost. As there's no server needed to do the inference, we don't need to keep a machine learning server running 24/7, so that can reduce your server costs. You just need to pay for the hosting of the website, and the rest works offline after the initial load. And then the fourth point is reach and scale. Anyone can link a web page, and that web page can use machine learning with zero friction. The flip side of this is not true. If you're trying to do this in Python, not everyone knows how to install Linux and the CUDA drivers and the dependencies you need to get that server running. So it makes it very easy. And maybe you're a researcher and you're trying to look to get real world usage for your new cutting edge machine learning model. And instead of just using the 3 people in your team to test it, you can get tens of thousands of people around the world to try your model with ease. And I guarantee people will use it in ways you've never even imagined, as we'll see today. Now, many of the demos today make use of our pre-trained models that we've open sourced, such as the ones that you can see on this slide. There's models for object detection, body segmentation, audio detection, and much, much more that are all wrapped into super easy to use JavaScript classes. So even if you have zero ML knowledge, you can still get these superpowers in your own applications. Now, if I just present back to the presenters for a second, it's now, of course, time for the show and tell. And I'm super excited to ask John and Var, who are up first, joining us from the USA. And they've basically created a theremin using TensorFlow.js. And for those of you who don't know what a theremin is, it's a musical instrument that allows you to play sound from thin air, essentially. So over to John and Var, who will talk more about what they've created.
Hey, good morning, everybody. It's so great. Greetings from Jonesville, Vermont, population 600. Can you hear me okay, Jason? Oh, well, maybe I should take this off.
Well, it's great to be here. Va, you there as well?
Yep, I'm here. You can hear me?
Great. So we're going to tag team on this. This was, so just by way of quick introduction, I'll introduce myself. Va, you do the same. My name is John Cohn. I'm the IBM fellow at the MIT IBM Watson AI Lab. I work on the MIT campus when we're not in the apocalypse. I live in northern Vermont, and my passion is teaching kids or anyone to fall in love with technology. And I'm somewhat new to AI. I've been a chip guy and a hardware guy for a long time, but now I'm running this AI lab and wanted to figure out a way to make AI fun. So that's my history. I've been at IBM almost 39 years, and between my wife's father and my wife and I, we've been at the same company for 83 years. But still kind of liking it. Va, you want to introduce yourself real quick?
Yeah, so I'm Var Barbosa, developer advocate at IBM's Center for Open Source Data and AI Technologies, and I live in Raleigh, North Carolina. And my goal is to try to make AI and open source technologies more consumable and more readily available to developers worldwide. And I primarily focus on, or I've been focusing on JavaScript, and that's what basically led me to TensorFlow.js.
Yeah, and he's really good at it. Okay, so let's tell you about Theremin. Let's first page there. So Theremin is a very simple application. It started out as we'll talk about as kind of a crafty demo that I did using a bunch of different components, Node-RED, Max MSP, just about everything I threw in it. The idea was I was asked to do a musical demonstration at an event at MIT, and basically wanted to emulate what's called a theremin. It's a musical instrument that's over 100 years old, created by this guy, Lev Theremin. And the idea is to be able to make somewhat beautiful music. Some people actually can play this as a real musical instrument by using the capacitance of your hands. So my challenge was to actually use AI, and specifically PoseNet, to try to create a musical instrument like that. I put it together pretty quickly with all these different components and hooked it up to, I like building Tesla coils, as I am definitely a real nerd. I love making, high voltage.
Very cool.
I coupled that all together. We put it together, and it was somewhat dangerous in every respect. It was dangerous from software, it was dangerous from high voltage, but people liked it. Well, let me show you just, so basically this is how it renders on a screen. I don't have very much light here, but as I said, somewhat beautiful music.
So unfortunately, I can't hear the music. Can you turn the volume up maybe? Or
Yeah,
yeah.
that's about, let's see, you're not hearing the music?
No.
I do believe that there's a Nobel Prize in solving the video conferencing.
Okay, let's see if I can play it for everyone on my side.
And the video is also in the presentation. So
Are you able to see it?
yes.
Okay, great. But basically, this application is, what TensorJS has done such a great job, because you could just give somebody a link or a QR code, and there's no download. It downloads the model, but there's no app to download, and it's you can even once you've downloaded it, you can even turn off your internet, so there's no backhaul, as you said, Jason. So it's fabulous, and bring it out, whether it's a school presentation or a bar or a CEO presentation. I use it all the time because it's a great way of showing people kind of bringing it in.
Okay, we just saw the sparks. We saw, yes, that's some very cool stuff right there.
Hey, so Va, I think maybe just in the interest of time, we can skip over. I sort of mentioned that how we had done it before, and the reason that we had done it was basically to get people interested in technology, allow them to sort of fall in love with AI, fall in love with applications like that. We've actually, and Va's done a really nice job of actually creating a bunch of tutorials so that even a really strong high school student could actually go, she or he could recreate it themselves. Why don't we skip Va just to go ahead to talk about how it's structured inside.
So I'm presenting on my side at the moment. Do you want me to go to, what slide would you like me to go to?
Yeah, so that slide right there, Jason, the one that starts in the end. Yeah, so unfortunately, I don't have a Tesla coil. And and I don't know how many people do. So what we ended up having to do is trying to make it a little bit more consumable to others who don't. So using some of the web technologies out there, like the Web MIDI API and the Web Audio API, we're able to create a browser-only solution, which combined with TensorFlow JS and PoseNet, and using your webcam, someone can easily run it in the browser, and the audio would actually come from the browser using the web audio. But if you have a web MIDI device and a browser that supports the web MIDI API, then you can connect the MIDI device to your browser, to your computer, and it'll actually be used as a MIDI controller. So you can actually, if you have a MIDI device, you can play it just like John was doing, playing it with his Tesla coil MIDI controller. And that's basically it. And if you go into the next slide, Jason. Yep. So in the links we have the resources. You can go to the first link there, the ibm.biz/Vermin, to actually play with the Vermin, launch it on your browser, and you can start playing with it. And then the second link is the GitHub link, where you can find all the code. It's all open source. It's all up there if people want to play around with it, modify it, add to it. Because there's some ideas that John and I had to improve upon it, but we haven't gotten around to it. So feel free to play around with it, add your own additions to it. And then we have the Medium article, which actually goes into a little bit of detail on all the technologies involved and how it was put together. And then the last two were the YouTube videos that you just saw. And I think in the interest of time, we can go ahead and wrap it up, Jason. So if you go to the next slide, it's just a QR code again, if people want to just grab the QR code and the link to the Vermin. And with that, I'd just like to say thank you to everyone for listening to us. And thanks to John for having a great idea and pulling me in on helping him with this. And you can find the slides at the bottom link that are there, ibm.biz/Vermin-slides. That'll have the slides that we just went through, as well as the links in the video if people want to play it out and try it out. So go out there, have fun, and thank you.
And let us know what you do with it. One quick thing to point out is that in the upper right corner, so the Git's at the bottom, And on the upper right corner, there's a link for some control settings. You'll recognize some of them from PoseNet, some others. There's a little instruction there. There's also a pointer to a link that brings up the QR code so that if you're at a party or something, you show it to somebody, just bring up that link, let them take a picture and then pass it on. So let us know what you do with it. Thank you so much, Vaughn. It's been so great working with you on this.
Awesome, guys. Thank you very much for sharing that with us. And if anyone on the live stream has questions for John or Var, do feel free to talk in the live chat. They are on live right now, so whilst others are talking, they can also be answering your questions as well if you do have any questions. So feel free to have a chat in the live chat. And apologies for the slight technical issues there, but thank you for sending me the slides. That's most appreciated. Awesome. So back to the presenters. If John and Var stop presenting on the Hangout, we next have Cyril from Paris, who has figured out how to draw in his face in 3D in real time in the web browser. So that's very interesting. And I'm going to switch back to presenters. Cyril, you are up.
All right. Hi, everyone. So thanks, Jason, for the introduction. My name is Cyril. Can you hear me okay? Excellent. So I'm a digital, French digital interaction artist based in Paris. And I will quickly jump through a few slides and maybe do a live demo. So
1 second, sorry, I'm having technical issues again. This is not my day at all. So it seems like my graphics card is like dying on me today. Let me rejoin this Hangout. 1 second. Let me just reset this. Hold on. Okay. Good. Okay, go for it. We're live.
All right. So yes, I've been working with technology for many years now, and I've had a long time obsession with face and augmenting the face or using your face to navigate. One experiment I've done with the face and machine learning was what I call a portrait matcher. Oh, and now it's gonna load. Oh, there we go. So here it was a couple of years back, just using face detection model to figure out the orientation of the face, and then throughout a database of tens of thousands of portraits from Google Arts and Culture, trying to match the position of one portrait in the database. So as I'm an artist in residence at the Google Arts and Culture Lab in Paris, and this is where I really came across machine learning and came to realize how this technology can really help open up a broad new range of interaction, a broad new ways of interacting with content on digital platforms. And so I've been pursuing this research for a few years now. An extension of that project was Art Selfie. So in this case, trying to match facial features to find a portrait that this time may connect with you on a very personal level by finding a portrait that may look like you. And some results were really, really nice. As I demoed it, it started as a very spontaneous, small experiment similar to the one I'm going to show. And it really resonated to the people we showed it to. So it became a feature in the Google Arts and Culture app that anyone could use. And it had a very good response. Millions of people have tried it around the world. So something that started as a very small experiment, just by being able to share it and show and demo, it became something that millions of people ended up using. So that was a very nice experience. And I'm really fond of that approach to keep experimenting and start something small and show it to people, and then use this feedback to see, maybe to find interesting ways to develop it, ways that I may not have thought of in the first place. So I started what I call an AI plus HCI degree. So just using available resources online, because there are so many, to try and learn how, as a designer, as an artist and designer, I can apply machine learning in my work. So as part of that sort of self-made program, I've I said that I would do 10 open source weekend experiments. So each weekend, starting maybe on Thursday or Friday, start hacking something and post it by the Sunday. The goal is to have a very constrained time frame, because, I mean, as you know, when we have so many ideas all the time, it can be hard to close the doors and decide on which one to do. But this became a very good proxy, a very good way to say, okay, I'm going to do this one because that's the one that I can do in 48 hours. So I've started doing these experiments and posting them online. And again, the receiving feedback online from people really motivates and helps find extension and new ideas and developments for these experiments. So I've been, I think I'm at the 6th one now, and the AR phase doodle is the 3rd one, and that's the one I'm going to talk about a little bit more. So the inspiration for this, apart from my long-time obsession with the face, were this idea that artists have forever and everywhere tried and extend the face and augment it through graphic and self-expression. And one thing that particularly caught my interest was the idea of going beyond the face. So start having features that start from the face, but then extend and go beyond. And of course, seeing the MediaPipe model from TensorFlow.js, this obsession became an implementation that was possible to do right now. So I started.
This is super cool.
Oh, hello.
Yeah, this is super cool. Nice one.
Thanks. And so yes, thanks to Three.js and the MediaPipe face detection model, it was possible to do a doodle tool that lets you draw on your face and go beyond the face. So having mustache, hair, apparatus, etc. One of the first challenge I had was to find a way to get a 3D model aligned with the face. My first tests were not quite conclusive, but thankfully, thanks to the beauty of open source, I'm going to just jump on the GitHub. Schwatticus shared a public repo that had an OBJ model that had the exact correspondence of the vertices that the MediaPipe model sends and its own vertices. So I was able to just load up that model and map it to the MediaPipe coordinates that are being sent. So that became easy in a sense because Schwatticus did the hard work. And then the question was to find where the mouse clicks on the face to be able to add a plane on which user can draw. And here again, thanks to the beauty of open source, the Three.js model, framework allows you to very easily project any point on the scene, find not only which mesh is being hit by the ray, but also at which coordinates at which UV coordinate. So really, again, all the hard work was already implemented by amazing developers from the community, and it was very straightforward to implement. So this is the debug view of how it looks like and how it works. Basically, you have this mesh. When you click, it projects a ray. It creates a plane on which you can draw. And every time you click on the face, it creates a new plane. So after some hacking, we can see at night and day and the next day. And by the end, at the end of the second day, it started working. So it's time for a celebratory dance. And let's do a quick live demo. All right, so hopefully you can see my screen and I can start drawing.
Good.
So as you can see,
yeah, really really sticks to the face nicely. That's really cool.
Yes, and you can get also the perspective. So here we can see that this line here is really aligned on the normal of my cheek. And it's pretty cool because you can also draw each parts are independent. So you can move your face and it will move each item independently. And if you should, you can always see the debug view here.
Very nice.
And the original goal to be able to go beyond the face. So the only limit is that, of course, you have to start the line on the face. So you have to start on the mesh. So this is why we can see here that the circle only appears when the mouse is on the face. So that's to try and give a hint as to when you can start drawing or not. So of course, because this relies so much on open source, oh, okay, it's not good. But this relies so much on open source. This demo is also open source, so please feel free to fork it, hack it, and have fun. So that's it for me.
Awesome. Thank you very much. I'm sure a lot of people are going to be forking that after this. Super cool demo. If anyone's got questions as well, feel free to write them in the live chat. And of course, whilst others are presenting, Cyril might be able to answer those for you as well. So do make use of the fact that everyone is live here right now. And this is your chance to speak to these awesome creators. So do ask questions in the live chat if you're feeling curious. Thank you very much. So next up, we have Follow the Dark Side from Tokyo, Japan. And he has used TensorFlow.js to produce a rather cool hip-hop video, which uses various invisibility effects and much more. So over to Follow the Dark Side if he is available to talk about that more.
Hi, Jason.
Hello there. Good, we can see you.
I show my presentation. Please wait. Okay. Can you see my slide?
1 second, let me just look for it. I need to pin it, I think, on my side. Pin. Yeah, we're good. We can see your screen. Go for it.
Okay, thank you. Yes, okay. Hello, everyone. I am creator and dancer and b-boy Follow the Dark Side from Japan. And that is my b-boy name is too long, so please call me FTD. And I'm not very good at English, so I think it's difficult to hear, but I ask for your understanding. Okay?
Sounds good to me.
Yes, I present about creative coding with TensorFlow.js and P5.js. First, I explain what is creative coding. To put it simply, creative coding is creative activities using programming, like playing music, and drawing, and cool videos. Of course, every person has a different definition of creative. But the important thing is if you are not engineer, not programmer, you can easily do your creative work. I was almost exclusively interested in dance when I was a student. But creative coding has broadened my horizons. So I want to say very thanks to the pioneers of cool creative coders. Okay, there are many tools that can help with your creative coding. Only a few are listed here. I often use Touch Designers and Open Frameworks. Today, I take one from the list. Processing is a famous creative coding tool. This is useful for creating cool and interactive visuals. And P5.js is a derivative project of processing. That is a JavaScript library. So you can do creative works on your browser. And TensorFlow.js is also good. at expanding your creative expression. Sometimes I use machine learning models by Python, but there are many problems in building my environments. But TensorFlow.js makes it relatively easy to use machine learning models. For example, if you can use CDN service, you can finish building your environment quickly. I have made some simple demos using TensorFlow.js and the P5.js. So first, I show you the digest video. Okay. Maybe no sounds, but it's okay.
We could hear some of the sounds when the video is playing. It sounded okay, I think.
Okay.
Cool.
And today I will introduce two my works. First, this is rhythm action game called Body Drum. By using PoseNet model, you can get the position of body parts. When the blocks comes up, you just hit the blocks like playing the drum. Thank you. And the interesting thing about this game is that the drum patterns are automatically generated by AI. That AI is Drums RNN model created by Google Magenta project. The Drums RNN can generate drum pattern like a kick, snares, hi-hats, and others. Magenta project offers other interesting models, so if you want to make your work more creative, you should check Magenta website. Okay. Next, this is purring noise visual effects. The characteristic of purring noise is that the values are continuous like a wave, not completely random. And the body peaks is a person and body part segmentation model. By adding purring noise to the segmented person's pixels, you can create a wave-like effect. This source code is also available on GitHub, so you can try it. So lastly, I show real-time demo using a web camera. So please little wait.
Sure, no problems. Always excited for live demos.
Can you see my application?
Yes, your screen is now presenting.
Okay. This is purring noise effects. This app using web camera and mic. If I say something, wave effect more hard. Yes, like
Oh,
this.
that's very cool. I didn't realize it was reacting to sound. That's very
Yes.
cool. Really nice.
And I can adjust the slider hello, like this. So if you are interested in this application, please check my GitHub account. Okay,
Yeah.
today's my presentation is finished. Thank you for listening.
Thank you very much. Everyone was super excited to see that in the chat, and there may be some questions. I think you've got some fans in the YouTube live chat, so feel free to talk to them over there as well. And thank you very much for presenting. So next up, if you would like to stop presenting on your side, thank you very much. Yep. Next up, we have Jalma from London, who has created some really cool live 3D face masks using Face Mesh, I believe, and a whole ton of other cool stuff, actually. So go check out his Twitter account. He's done some really cool things too. So over to you to tell us more.
Hello, can you hear me? Excellent.
Yeah, we can hear you.
Okay. I haven't prepared like many slides actually. It was
That's fine. Live demos or whatever is all good too, and just chatting.
Cool. My name is Jaume. I work in data visualization at DeepMind here in London. So yeah, there's a lot of dealing with models and training. I don't really deal with actually training models. I just use pre-trained models. And we try to like integrate the back then DeepLearn.js, what became TensorFlow.js, into our workflow. It was still like a work in progress, so every now and then we try to go back and bring it. I saw Cyril's demo and I thought, oh, that looks pretty cool, pretty straightforward. So let's give it a go. This is most experiments I do in my spare time, so it's not work related. So let me see if I can show the entire screen, because what could go wrong, right? Share. Okay, you should be seeing all of you.
Yeah, we can see your screen, looking good.
Okay, so basically, I brought the model in and like started mapping things, you know, like saying like this, for instance, this is the usual, you just take the points, use the triangulation data, everything that was available, and things happen. So for instance, this is the first term clipping my face through the camera plane. So things to figure out in 3D, discover that it's not really a 3D face that is transformed, but rather a set of vertices that get distorted to fit what the model sees, which is like not what you would expect as a 3D graphics programmer. You would expect transforms for the model, but at the same time, it makes sense because that way it can be distorted. So, I mean, it's a different way of building these things. So one of the things that Face Mesh doesn't have is like you don't get UV mapping of the original, like of a texture right away. So I had to build my own, like click point by point and find the UV coordinates, which was a bit of a hard work. So it's something like, it's like Michael Scott. But yeah, it was basically building this one by one until I've got everything there.
So was this more like trial and error for you, or was it like, did you have any kind of background in this? Like, how did you figure this out? I'm just curious, but I'm sure others are curious too.
So I found the mesh that it's online, and I built a web application that you basically set the vertex number and click on screen, and it would store it. So it was excruciating. But then I talked to the team, the MediaPipe team, and they actually had the data. So they made a pull request and released it. So that's now on the TensorFlow repo, and I was able to replace my data with the actual data and start mapping things. So I got some results like then you can have like the face in 3D. You can actually shade it. You've got lights, you've got shadows. You can place things. So what I add is so there several things happened with this project. So I created a custom element that simplifies getting the user media stream from the browser. which they can be used in a phone, and it gives you like a rotating. You can go through different sources because like in a phone you have like several cameras with different lenses and different facing. I also related to that, I built the virtual webcam Chrome extension, which I think you're going to talk about that later.
Yep.
Okay, so I'll but yeah,
But
basically.
feel free to talk about it a little bit as well, because you obviously cracked that before me for the webcam hijacking. So feel free to have a little chat if you want about that.
Yeah, I mean it's basically a Chrome extension that allows you to like add like hook into a webcam and then perform something in there. Actually, I can show you later. Anyway, so there's more experiments. Then there's like 3D mapping of the video feed into the 3D object, which means like turning the actual mesh coordinates into video coordinates. And then once you have a 3D model, you can start doing weird things like repeating your face and stenciling.
I've seen a lot of very trippy effects on your Twitter account.
Yeah, I'll show them shortly. And then there's this thing like, so Nars Barkley crazy video. It's so one of the things was like this Rorschach mask that it's something that you can use for like displaying something on your face. So it's so the video itself is like a Rorschach video. So what I did is like I took the YouTube video and mapped it back into my face. And I'm hesitant to like show anything that it's real time because of, I guess, music license is going to be an issue.
I see, sure.
So I don't think I should. But basically, like you can play the video on your face as you sing along with the video. And
yeah, very cool. I mean, we can put the link to your tweet or something later on or something in the description afterwards for people to find the live video demo that you recorded.
Yeah, probably. Okay, so most of the data goes into like so this all comes like back to what Cyril said that he had to figure out so many things, and then I realized like that's gonna like artists shouldn't be having to deal with this. Like I think that artists should be concentrated on like creating the cool stuff, not like finding orthogonal bases for like mapping things, unless they actually want. But you know, it's something that as engineers we can fix, and then artists can do cool stuff. So I built this helper for, it's called face geometry. That's a mouthful. But yeah, it's basically a Three.js helper. It's a buffer geometry based helper for interfacing with face mesh data. There's like the documentation and then some stuff. So the usual, like the basic, you still see my screen, right?
Yep.
Okay. So so the default case in which you'll just track your face and then map something. So this with like a physically based material. And
that's so cool.
And I added this tracking function that basically uses several points in the geometry and calculates the orthogonal base, but it's correctly rotated. So, you won't see it here because it's a sphere. And then it's when you realize that this is all an illusion and there's no real 3D face to this, because as I get closer, it's bigger, but it's not getting closer, it's just getting bigger. So when you put this effect into a 3D, like a VR environment, you realize that the face is just enlarging. It's not getting closer. It's a bit trippy. So yeah, this is the basic case. Then you can do the similar thing, but like mapping video back into your face, which is like a pass-through, but then you can combine things, and these objects are already like so you can see like this halo thing rotates with my head, which is like convenient. So you just provide 3 sets of coordinates and get the rotation matrix in a position that you can use. So once you have the 3D mesh and you have video mapping, then you can start doing weird things like using WebGL instancing methods, which means like repeating a lot of render geometries. So you can do things like this and start like going crazy, like create a torus of your face.
Amazing.
And it has like lights and shadows, like you get everything. What else? Then this is the classical just transfer. So it crosses like it reads from two face meshes. One is for your video feed, the other one is for an image. So you just like drop like the image and get that, and then you start like trying if like something like other faces are.
You can literally wear any face you like. This reminds me of the Game of Thrones episode where they can like wear people's faces and become different people. You've literally made that almost almost real. That's awesome.
Yeah, I mean, it doesn't. We still need like some better blending and like color estimation, light estimation. But yeah, it's pretty promising for.
Yeah, totally.
It takes like a few lines. And the last one, it's of course, like flipping things from both from the same video. So it's like you try to identify two faces and then like place them.
The classic face swap. Brilliant.
So it becomes quite easy with this. I think so. And I have a few more experiments because this is like mostly. You stop sharing? Okay.
Very
still
cool.
So yeah, I built this helper, and then there's a bunch of experiments that I haven't released because they just halfway done, like signal spectrum into your face and like infinity recursion of your face inside your face, and it becomes interesting when you just have to concentrate on the actual rendering, like handling of data. But yeah, it's pretty cool. Like include like few scripts or like use require with your depending on your bundling process, and start doing things right away. Yeah, and it works good enough on phones, and yeah, you can do all kinds of stuff. One of the things of the virtual webcam was like, since we're all using webcams for like we're putting our face to like test all these things, you might want to do something like consistently repeat the same data, so it lets you pump back like something that you already have through a webcam. Like it's transparent to the system. It just looks like actually. Does this, like, have we tried this? Like if I just install this, yes, probably have my development version anyway. And then what I was doing is I probably also like trying to pump from a YouTube video back into your webcam, so you don't actually have to deal with any other pipeline, because loading videos from YouTube from the browser, it's slightly complicated. So
I
this
see.
should
Yeah.
be an improvement. So yeah, that's so the GitHub repo is there. Same deal, like everybody that wants work it or play with it or create pull requests.
Awesome.
Yeah, that's pretty much me.
Thank you very much. Yeah, but a lot of people are super excited in the chat there. I see a lot of people looking very impressed in there. So I think, once again, some people are going to be checking out your GitHub after this for sure. And keep up the great work. I'm always excited to see where this goes as well, because some really cool research going on there. So thank you very much.
Yeah. Thank you.
Cheers. Next up, we have Olesya from Russia, and she has a couple of demos that she would like to present to us today. I've seen a lot of her work over the past few months, and she's been quite a frequent contributor to TensorFlow.js demos. So please, your time is now.
Cool. Hi, everyone. Hope you all are doing well and love my background. My name is Olesya, also known as Mona Lisa. I'm an internet artist. My brush is artificial intelligence, and my canvas is your screen.
Very cool.
Today I will talk about my projects with TensorFlow.js and their similarity. So I now need to share my screen.
famous screen share. Let's see if the demo gods are kind today.
So now you see my screen, yes?
1 second, let me make sure I pin it on the Meet. Yes, we can see your screen.
Oh, great. Just take a look at my first project that's called Make Me Big, where font changes size based on your position in front of screen. It becomes smaller if you are close to a screen and bigger if you're far.
This is really
then-
cool for accessibility. I mean, like, you know, if I've got bad eyesight, I have to wear contact lenses. So if I'm further away, I can now read the text, which is great. Very cool.
Thanks. And the second project and the most popular is Fixed Posture. It tracks your posture and blurs the screen if you are sitting poorly.
Also quite needed in today's working at home situations. I think a lot of people can benefit from not slouching.
Yeah, probably. These projects seem too different. You probably are thinking right now, where is their similarity? So they're really different, but there is one thing that connects them. And this thing is PoseNet model that detects all body parts. It gives only one output, but also a lot of space for imagination. For all these experiments, I used libraries P5.js and ML5.js that let to write less code. So P5.js is for canvas work and ML5 is for machine learning.
Cool.
It needs to be loaded.
Yeah, Glitch can take a time to load sometimes. It'll get there eventually, though.
How Fixed Posture works. Firstly, it asks a person to sit correctly and store vertical position of eyes. Store our first position of eyes. After that, it detects vertical position of right eye every moment and finds the difference between start position and current position. And compare it with a constant. If the difference is less than the constant, it's okay, you're sitting good, your posture right. And if the difference is too big, it blurs the screen because your posture is bad. So there is a Make Me Big. Make Me Big. How text changes size in Make Me Big? At first, it calculates the distance between eyes and stores the first distance. It's like a start point. After that, it multiplies the distance by a constant. There is a complex formula verse in code. So that's all.
Awesome. Thank you very much for sharing. And all of these are available on Glitch, I presume, so we can share around the links afterwards. Cool. Thank you very much for presenting. And yeah, we'll share the links to the demos afterwards if you want to play them after the show as well. So thank you very much. Next up, we have, who do we have? Alexandre from France. He has been experimenting with some super cool technologies, including mixed reality, WebGL, and TensorFlow.js, of course. And that allows him to bring to life a person from a magazine and bring them into the living room. So over to you for your live demos and good things.
Hello, can you hear me well?
We can hear you well, loud and clear. Yeah.
So let me try the present now button, the frightening button. I go for
Yes.
entire screen.
Let's see if it comes up.
I hope it works. I've chosen an easy solution to make the demo. So in augmented reality, it's a bit complicated.
We can see your screen. Everything's
It's
looking good for now. Yeah.
super cool. So yeah, I'm gonna be talking about how can you create holograms out of pictures. So let me just introduce myself. What is that? Yeah. So I'm Alexandre Deveau, working for the French National Mapping Agency in Paris as an engineer in geovisualization. So I've always been passionate about reanimating things, like creating life out of fixed images, for example, because we work with a lot of aerial data, satellite images, and usually fixed data. So just to show you, I have no idea if it works there, just a second. That's something I did a few years ago already, is just how to automatically reanimate old images. I mean, old images, fixed images from satellite or plane.
Oh, that's really interesting. That's cool.
Yeah, I don't know if you can see the cars moving, the water is
Yeah,
moving.
yeah. You can see the cars and the boats and things, and the clouds especially. The clouds are cool.
So this is actually working in real time, but the segmentation has been done before under the form of land cover. So it's not using TensorFlow.js, but that's a really cool things I would like to try. But let's go back to my small demo today for you. So I've done a very simple slide, probably the most ugly of this morning, but at least you can see how simple it is. So I will show you a few videos to show you how it works. But basically I use TensorFlow to segment the image or movies. I also did it with movies. And I use WebXR, which is actually available now on every Android phone using the last Chrome. I mean, you have to get a pretty recent phone, but it's supposed to work. So mixing those two together creates some funny stuff. So let me show you how it wonders. So the first demo I did was this one. I hope you can see the videos. I don't know what the quality is though. Yeah, that was one of my first try. So basically you go with your phone on a specific web page I created. So you can take the image coming from your camera and then we segment the image, extracting. Here we extract the whole silhouette, but it works also with the face, and we can get more specific stuff. So everything is done using the BodyPix here, the BodyPix model, which is working in TensorFlow, which is really, really cool. So I did different stuff on it. So yeah, a bit more recently, I did other tests. So you can actually make it work really easily. Every time you take a picture, we create a new segmentation, and then we create this holographic effect. I will show you very fastly how I did the effect. It's pretty simple, so you can see that. And yeah, just one last for the road, a bit more recent. I did also spend some time testing with the face mesh model that we just talked with Cyril before and Sanchez just before, and it's really, really cool because you can extract the face and get the 3D mesh out of it. So I did tests to mix those two models that both work with TensorFlow.js, so it's also very powerful. The possibility to mix different models is really strong. So let me just show you.
And the last two, they actually speak as well, right? If I remember correctly, they actually say hello.
Yeah, they do speak, but yeah, I can show you. I did it. It was this. So I don't know if you can see that. So it's really cool because I can speak on a pre-recorded video, or they can speak live with you speaking with the front camera. I was really surprised that it works. Like when you go in WebXR with your phone on Chrome, Google Chrome, you can get the XR, which is using your camera from the back of your smartphone, and also the camera from the front. I had no idea you could use both, but it works. So you can actually talk, and in real time with the face mesh, you can make anyone talk. So it looks pretty crappy because I didn't spend so much time, and it's, to be realistic, needs a bit of work. But you can see I can change my face to Michael J. Fox here and make him talk. And this is cool because it's real time. It's pretty cheap, but it works, right?
And running on the phone as well, right? This is all running on, I guess, a modern-ish phone.
Yeah, it's 2 years old, LG G7, but
okay, nice, yeah.
It's a good start, I think. So So yeah, just briefly, so I just explained before, basically you grab the image, I sent you an example here, and then you use the segmentation, which is done really fast, but you don't really care, right? It's like a few milliseconds, depending on your power on the GPU of your phone. But you have to do it just once, so you don't really care about the time. So I did use body pics. Offline, I did use some other depth estimation stuff for movies, but on the phone, I use body pics and face mesh using TensorFlow. And then for the rendering, which is the cool part, which makes it look a bit sexy, is just to, I did mix different type of rendering, but the first was particle rendering. So I'll leave you the link for the interested people, and I need to update this code because I've done a lot of different optimization, and some people put me some issues. Very cool, because on some phone like the Pixel, there was some problem with my camera picture. The grab frame functions was not working perfectly, stuff like that. So you can get the code here if you want to test some stuff. So I will update it with the face mesh algorithm. Yeah, just to show you another video. This is what I do also with the movie. So basically here it gives you an idea of what it's extracting if you mix models. Here we mix the body pics model, which is extracting the silhouette of the people. And we are also using here, this is not Midas, I think it's Megadeth I was using. So you can also estimate very fastly the depth of any image now. It's really, really powerful too. So again, in my tiny living room here in Paris, you can see that video, and you can see some
cool.
particle rendering.
Get the depth out of there as well. That's really nice.
Yeah,
it works
looks
surprisingly well, actually. That's really nice.
Yeah, it's still a lot of improvements to do if I have time, but at least it's really, really funny. So I did also, just to finish that, I did some tests with some Visio conference. So maybe some of you know WebRTC, which is, I mean, today, like the web is really full of nice API. So we get the WebGL for the rendering I just showed you with a particle. So any browser can render some quite high definition 3D rendering. And now you can use the augmented reality in phones. With TensorFlow, you can use some deep learning. So we really have a nice platform to develop. So this is just, okay, put off the sound. This is just a live friend of me talking. So it looks pretty ugly. It's not Minority Report rendering yet, but it's one of the tests I did. So this is using a mesh rendering. It's not particle, I think. I did mix some stuff.
Very cool. Nice work.
Yeah, a lot of stuff to play with these days. So yeah, that's all for me. If you have any questions, feel free to ask me in the chat. I put some stuff on my Twitter for some demos.
Perfect. We do actually have one question in the live chat. Actually, someone's asking, what was the library called that makes the depth estimation?
The depth estimation was the one I show you. I think that was Megadeth. So Megadeth, I made it run on TensorFlow, but not in the JS version, right?
Okay, cool. And yes, for all those people watching, we will put any links that are available up in the video descriptions after the show has ended. So you can go to all of the things you've seen today. If people want to share, then we will put those links there for you
to share them.
Excellent. So that will all happen after the show once I've got a moment to edit the description. Cool. Thank you very much for presenting.
Thank you.
Yeah. Next up, we have Amruta from India, and she's also made quite a few things, and she's going to go through some of her work today as well. Over to you, Amruta.
Thank you, Jason. Hi, everyone. This is Amruta here. I work on applying AI and machine learning algorithms in multimedia and entertainment technology domain. Today, I want to show you a few demos. The first one is very similar to, I think, the two demos you saw earlier by other presenters on music generation. So here I'm using from TensorFlow JS to generate new music. So you can just see the video and then I'll describe how exactly I implemented it. So this is pretty simple implementation. I used hand pose model for this. What it's doing is essentially capturing the position, like your basically hand movements using hand pose model. And then the coordinates of your hand in this left video, it's trying to map it on your canvas here on the right hand side. So let's say if your hand position was here, it will try to trigger those corresponding grid cells on the canvas. So for simplicity, I have divided the canvas into small 80 by 80 cells, and each cell will produce some sound. This can be essentially a function of the row and the column, X and Y. So let's say if this was the third row and fifth column, then you can generate sound with some frequency, which is a function of 3 and 5. Otherwise, I have also another version. It's under computational music in my Git repository. So my Git repository you can find at github.com/pamruta, and under computational music, there is another version where same piano box you will see, but the grids, they will correspond to piano keys, like the black and white keys on your piano. So from A, B, C, D, E, F, G, and then the black notes will be the sharp notes. So there is a version, both two versions are available. One in which you're just producing some sounds with frequency, which is a function of X and Y. And the second version where these grid cells all actually correspond to piano keys. So it's very simple, like it's just taking your hand coordinates and it's triggering those cells. So again, you have two options here. One is a polyphony, where let's say you capture all the 5 fingers, let's say the position of all the 5 fingers, index finger and so on. And then it will generate 5 sounds at the same time. And then there is another version without polyphony, in which I'm just using one single finger, let's say index finger or thumb, and just producing single sound. So you can try and experiment. There is a lot of, I think, extensions possible for this demo. The second one I want to show is actually very simple implementation of MobileNet. So I have actually 2-3 demos which are like all very similar. They all use just one single model, which is MobileNet, but for various different things. So here I'm just running the plain vanilla MobileNet model on wildlife documentary film. So you can see that the MobileNet is essentially image classification. I'm running it on wildlife documentary, and it's just basically labeling this video frame by frame. So it's going through the frame and then trying to label each video. And the beauty of this MobileNet, what I've noticed is that it's giving you not just the common name of this animal, like African dog, but it's also giving you the scientific species name, which is very useful. So this is primarily can be useful for video indexing, multimedia search and retrieval. So let's say if you're primarily interested in watching documentaries about certain animal like dolphins, about whales, about tigers, you can label this video, let's say between X and Y, let's say from 1 second to 5 seconds, I'm seeing this particular animal, and then use it for search recommendation when somebody's is interested in like searching videos with specific animals in it.
Yeah, that's cool. I can imagine if I went to the zoo, I could go, okay, show me all the clips of pandas and make a new video from that for the panda highlights or something like this. So it could be very useful.
Yeah, because the internet has a lot of videos, and on YouTube especially, you have to manually tag those videos that, this my video is about so and so. Whereas this is automatic video tagging, so you can just automatically generate these kind of metadata or tags for your video, and essentially search videos which contain specific animals, contain specific things. So this is the plain MobileNet model, but you can also customize this model for various different tasks. So here I have customized the same MobileNet model, but for sports activity recognition. So this video has a lot of clips from Olympics, different games, and it's basically labeling those videos by recognizing the sports activity. So you have some videos, let's say about swimming, skating, figure skating, ice skating, cycling, horse riding, and so on. So you can see that the video is playing on the left side and it's tagging. This is MobileNet model, the exact same image classification model. Is taking the video frame by frame and trying to figure out what activity it is. But here I had to customize it, and that customization is pretty easy. I'm just using like training video, grabbing few screenshots from this video, and then training a KNN classifier, which is basically saying that, let's say this video, I pause it at this moment, and then I see this is a figure skating, so I'll try to label it as figure skating. And in the training part, it will just add this example, like take this video from this canvas, generate a feature vector using the pre-trained MobileNet model from that image, and then add this example into KNN classifier. So this is very simple way to customize, any pre-trained model for your own task. And that's essentially basically what the teachable machine is also doing. So the third demo is like, you can see 3 different things I have done just using MobileNet. One is this video, the animal tagging. One is sports activity recognition, where the customization of MobileNet for sports activity recognition. And this is the third one where I'm using the same idea, but for classification of food and restaurant menu images. So I have trained this teachable machine classifier to recognize different food items like burgers, cake. So essentially you have to just load some sample images and tell the classifier, this is what the cake looks like, this is what the juice looks like, this is what noodles look like, and so on. And if you can just, this is like a very nice browser interface for running the same task. So you can just upload any image and just basically, this is my test sample where I'm just loading some images, and then it will tag those images automatically for me, saying that I see noodles in this photo.
Nice.
Or if I just load something else, it will basically tag that video as tag that image as a cake. So 3 different tasks, just using one single model, which is MobileNet from TensorFlow, is what I wanted to show you essentially today. That you can do a lot of things just using one single model. And the other one was just extension of hand pose, what you saw. I think the drum machine from FTD and John's theremin, the same concept for music generation using hand pose. And there are many more demos you can find on my website, so feel free to browse through. I have a lot of other demos as well. You can feel free to browse and also check out the Git samples.
Perfect. Thank you very much. Some awesome demos there. And once again, I'm sure people will be checking out the Git repos after the talk as well. Thank you very much.
Yeah, feel free to post any questions if you have in the chat window. I'll be happy to answer them. Yes,
please do put questions in the live chat whilst people are still here. I'm sure they're happy to answer. So do get your questions in before people disconnect later on. And then finally, we have Shan, all the way from China, who is the creator of Pose Animator, which allows you to animate SVG graphics in real time using PoseNet and BaseMesh. So over to Shan for more details on that one.
Thanks, Jason. Hello, everyone. I'm Shan. Hello from Shanghai here. First of all, let me just say thank you to Jason for organizing this event. It feels super surreal to have everyone dial in from different parts of the world and share all this really inspiring work on TensorFlow.js. I got so many ideas from just watching all the cool demos, so it's great.
Awesome. Thank you.
Let me maybe just jump into the demo right away. Can you see my screen?
Yep, we can see the screen. All looking good.
Okay, great. So this is basically what Pose Animator does. So it takes the live camera feed and runs PoseNet and face mesh models on top of it, so that it extracts the key points from the markers here. And once it has that, it animates a pre-prepared SVG file in real time, and basically turns you into a talking head with a cartoon style. So you can pretty much any SVG file you want. So if I want to turn into a boy illustration here, I can get that. And it picks up your motion all over. It picks up your whole body motion. So so if I stand up and take a few steps back, we can kind of see the whole body animation. Like
That's
this.
so cool. And I love how robust it is as well. Like even when parts of the body are out of frame, it still manages to cope very nicely, in fact. That's really awesome.
Yeah, I saw like somebody, like some of the best pictures were created from like this little glitches.
Oh, you push it to
like
its
when
limits
you're
there. Oh,
like
there's the
going
head.
out.
Very cool.
Yeah, could
Very
get some funny results. So maybe let me share this tab instead. So I would like to share a little bit about how this whole idea started. So it actually started from an experiment I was doing starting in March. And by the time I was in Shanghai and this whole COVID crisis was pretty intense at the time in China. So everybody was pretty much stuck at home. And I was like, being just a software engineer, how can I help with the situation? I was feeling pretty helpless at the time. So I've been a longtime fan of generative art and basically just generate graphics from very simple shapes like squares and circles and everything. So I had this very, very cheesy idea of generating a greeting card so that you can share with maybe a loved one who you haven't been able to see for a while, or someone you feel really grateful for. Maybe it's the nurses and doctors in the front line. So I had this really rough idea that starts from taking a picture and then extract the key points using PostNet and FaceMesh. And I would let people take a picture of themselves, imagine that they're holding a imaginary flower bouquet. And then I would read the pose and then generate this whole nice illustration from it. And then finally people can write a little nice message in the corner and send it to someone.
That's cool. That's nice.
So this is sort of the I wanted to go for. So in March, so I made a deck about it and I shared it among a few friends, and they're like, "This is nice, but it feels really, really cheesy." And in retrospect, I agree with them. But that's what the circumstances calls for. And so some people was like, maybe it was a little too late for COVID because China's COVID situation was getting better very fast in March, which fingers crossed will be what is eventually happening for the world very soon. But so I started prototyping this idea, and this is a very rough first version of the prototype. So as you can see here, it already has the bare bone flow of the pose animator. And what's happening here is I'm drawing everything mathematically. So basically nothing is parsed from a predefined SVG file. I'm reading in the key point. And so for example, if I have the key points from the face, and then I would define a coordinate system, basically the transformation space from just the key points from the face. Take the left ear, take the right ear, draw a vector that points towards the right ear, and then it would become the x-axis. And then rotate it 90 degrees to get the y-axis. And then I would just draw the curves mathematically. For example, move 3 units to the left, and then go to 3 units to the top, and then basically you get the idea, draw the whole thing. And then apparently the flower bouquet can be defined by a circle that is drawn from the left hand to the right hand. And I was planning on using circle packing to pack up the round shape to get a nice flower bouquet. So as I started experimenting, I quickly realized how time consuming it was, because in order to get a full illustration, the little simple figure here on the right took me about a full day of just banging my head against the wall and try to get all the math right. And but there's really something coming out of it. It's really quite expressive. So I liked how real time it feels, but I wanted to be a little more lazy and be able to borrow some illustration paths from elsewhere. So that's where I got the idea for Pose Animator. So basically, I wanted to borrow the editing power of other illustration softwares, for example, Illustrator, so that you can draw the paths in the software. You can go as detailed as you want, but then you can, as long as you include a T-pose of the skeleton, you can start drawing around the skeleton. And then when you drop this file, you will have to export this file as an SVG. But when you drop this SVG file into the tool will automatically pick up the relative location for each anchor point to each of the bones, and then compute a weight for the bone's influence for the anchor points. And then when the bones animate, the the anchor points will be animated as well. So the idea is really not that brand new. This is actually the base for all the skeleton based animation these days. I have a little diagram here. I would like to enter the contest for the ugliest illustration for today's show. But
no, it's very cool. It's nice to see all the
anyway,
doodles behind the work, actually. This is really nice to see.
Thank you. So say if you have a vertex, I will compute the distance from the vertex to all the bones. And then the weight or the influence from that bone to this vertex would be computed by this formula here, which is 1 over the square distance of the square distance. And then once you have all these raw weights, I would sum it up to, I would compute its sum and then normalize all the weights to add up to 1. So the algorithm here is really borrowing from this algorithm called linear blend skinning that has been used in the animation industry for many, many years. So if you want to read more about the details of the skinning algorithm, there's a blog post recently released on the TensorFlow blog. And you can read about all the geeky details there. So basically, this is what the full body rig looks like. So there are 90 key points. I went through the same painful process some presenters mentioned earlier, which is to go through the key points returned by FaceMesh one by one. And FaceMesh returns 400 key points, so there's really a lot of them. But I handpicked several ones to represent the contour, and then PostNet only has 17 key points, so that's a lot easier to handle. So in the end, this is the structure I ended up with. And because of the SVG format, which is really awesome, this idea is generally applicable to any kind of vector graphics. So if you have some illustration already ready at hand, maybe as saved as a Illustrator file or as an SVG, you can easily tweak it to embed this skeleton into your SVG file, and then make sure the file follows a certain structure. With these easy steps, you can drop your file and see it animated right away. Part of the reason why I created this tool is I want to make a tool for artists to make their illustration come to life with a few easy steps. And I've really been enjoying seeing what people have been creating with it. And this is one of my favorite examples created by Julia on Twitter.
Yeah,
so she was just,
cool.
This is why I would totally let the illustrators and the designers out there design all the is awesome. That's it for Post Animator. I would love to see all the awesome creations that the community can make. And if you want to read more details on the tech part or forked up code on GitHub, everything is open source. Feel free to play with it yourself. Thank you so much.
Awesome, thank you very much. And I also am very excited to see how creatives are going to use this. I've already seen some chatter on Twitter and LinkedIn where people in the animation industry are like, oh, we can now use this to kind of do our 2D animations and all this kind of stuff. So super excited about that. And obviously, my natural question is, will there be a 3D version one day? Maybe, I don't know, maybe that's in the pipeline. But this is super cool work. Thank you very much for sharing that. And I love that you put all the slides there showing your thought process as well, because some people in the chat were just mentioning often you don't realize how much work goes into some of these demos, and it's lovely to see how you evolved from these sketches just for Mother's Day and other things like this in March to this whole system that does all this animation for you. So that's super awesome. Thank you very much, Shan. Cool. So finally here, I've actually got a couple of demos of my own just to quickly finish up with. So going to switch over to my Chrome over here. So actually, this is very similar to what someone just showed a little bit before. I made this a little while ago, but essentially it's combining WebRTC with all this stuff. And this is the famous JSON dance that you might have seen going around Twitter recently. And I can then project myself in different rooms or different locations and have a conversation with people in a more immersive way. So teleportation is now possible, which is quite nice. And then the second one I want to quickly show you is the ability to make TensorFlow.js work in a Chrome extension, as you see here. And what's cool about this is that it's running in the background process. So that means that when you reload a page, it's not going to reload the machine learning model every time. And that's really useful for efficiency and bandwidth reasons and all that kind of fun stuff. So now we can actually join Google Meet meetings or Zoom meetings looking however you like. So here I'm just using body pics, but you can imagine how you could change the background or blur the background or maybe transport yourself to a different world. Or if you saw my first invisibility demo, you could literally remove people if they were behind you. So and just make them completely invisible. So the possibilities are endless. So with that, thank you once again to all the presenters today. It's super cool to see all the great things you've made, and I'm sure it's inspired many of the people watching to take their first steps too. And on the notes of first steps, as I mentioned, do check out the beginning and the end of our first show and tell, which is pre-recorded on YouTube already. And you can use that to learn how to take your first steps in just a few minutes. Such as some of these kinds of things, which I can show you now. Teachable Machine, that you've actually seen being used a couple of times today already. In just like under 2 minutes, you can learn to recognize anything in your bedroom in just a few seconds. It's super, super cool. And if you're new to machine learning, new to JavaScript, new to everything, I highly recommend just trying this out, and you will get good results for a first prototype, essentially. The other thing I just want to point out very quickly is that if you want to get started with some boilerplate codes, something a bit more hands-on and codey, we've made some really nice boilerplate code on glitch.com. If you go to glitch.com/@TensorFlow.js, there's some things here for like object detection, image classification, body segmentation, all that kind of stuff is available. And you can fork those and then turn that into your own project very easily. And we've got the same stuff over on CodePen as well. If you prefer CodePen, you can just go to topics on the left-hand side here, click on TensorFlow.js, and we've got the same tutorials here for you to get started as well. So both of those are really easy to use to get started in minutes. And with that, I'm just going to go to the presenter view one more time so everyone can wave goodbye. Let's go to tiled view here. And whoever's left, if you want to wave, feel free. Thank you once again to all the presenters for joining today. And I hope that, well, you had a lot of fun, and if you have any feedback of what you want to see more or less of in the future, do let me know on your YouTube, Twitter, LinkedIn, whatever you want to do. And of course, if you're making anything with TensorFlow.js, do use that made with TFJS hashtag so we can find you and invite you to future show and tells and maybe even events in the future once we're allowed to go out again. Now, one final thing to say is we will be having a private hangout after this live stream is over in just a few minutes for anyone who wants to stay on to ask questions privately to the presenters or to myself. And we can just have a private thing that's not going to be streamed live, so you can ask questions without having the fear of being recorded forever. So I'll send the link around for that in just a second. But for now, that wraps up the live part of the stream. So thank you very much for watching. Cheers.